Today, on how it's made. Alkaline batteries. You'll get a charge out of this story. Wheelchairs. The making of mobility. Flutes. Seeing how production plays out. And cowboy boots. How'd he make 'em? A battery produces an electric current when its positive end, called the cathode, and its negative end, called the anode, connect via a conductive pathway in the battery-operated device. This pathway conducts electricity when three components, two electrodes and an electrolyte, interact. These alkaline batteries are the rechargeable type. They last for years, depending on how you use them. The factory begins production by cutting nickel-plated steel into oval pieces, then gradually shaping each piece into a tube called a console. The console houses some important chemical ingredients: graphite, which conducts electricity; silver catalyst, which reduces chemical pressure buildup; manganese dioxide, the main ingredient in the cathode; barium sulfate, which binds the cathode ingredients; zinc, the main ingredient in the anode; a gelling agent to keep the zinc particles suspended; and finally, potassium hydroxide, which interacts with electrodes to produce electricity. This 25-head press shapes the cathode's powdered chemicals into hollow pellets. The press churns out 25,000 pellets an hour. A machine called the console press then inserts 3 pellets in each console. 3 because these pellets are so fragile that 3 smaller ones are easier to manipulate than 1 big pellet would be. Here's the insertion in slow motion. The next machine makes a ridge on one end of the console to help seal it. Plastic holders, called pucks, hold the consoles still as nozzles apply a sealant to the top, which is the negative end of the console. Next, they cut a roll of paper into small strips. These strips are called separators. They have microscopic holes that permit the flow of ions, electrically charged molecules, between the cathode and the anode. A hot melt glue machine deposits a small amount of glue into the separator, now rolled, and seals the positive end of the paper tube. The glue cools and hardens over the next minute and a half as the consoles move along a conveyor. The next machine injects an electrolyte, a potassium hydroxide solution. It takes 9 minutes to soak through the separator liner into the cathode pellets. Nozzles then inject about 4 grams of zinc gel into the anode cavity. Only about 2/3 of the gel weight is actually zinc. The other third is this company's closely guarded trade secret. It's what makes these batteries rechargeable. The zinc gives the gel its silver gray color. A welding machine fuses 4-centimeter nails onto the cap of the battery. This is where current collects before it's discharged. The machine ejects the cap when finished, and another machine inserts it into the negative end of the battery. This cap includes a safety feature crucial to rechargeable batteries. It can resist high pressure, but if heat or power surges cause excessive pressure, a tiny vent prevents the battery from exploding. The machine folds over the console lip to enclose the contents. A rotating 3-headed crimping machine then makes a ridge in the finished battery to reduce the chance of leakage. An electrical testing machine contacts each battery for 200 milliseconds to ensure it has at least 1.5 volts. These batteries will be ready to use right away. No need to charge them first. The labeling machine uses light sensors to time the labeling of each battery casing. The plastic label lists technical information and adds additional insulation. Then, 3 seconds in an oven at 198 degrees Celsius shrinks the labels to a tight fit. Spain's King Philip II was the first disabled person to get around on wheels. He ruled from a rolling chair with footrests in the 1500s. Today's wheelchairs are widely available, but at a princely sum of anywhere from $2,000 to more than $12,000, depending on the features. This wood, leather, and steel chair is a World War II antique. A modern wheelchair literally runs circles around it. With more than 150 possible design options, today's wheelchair fits the user and the user's lifestyle. The wheel rim is aluminum, the spokes steel. It's much like a bicycle except for these 6 steel brackets that later fasten to a hand rim for propulsion. Tires are either pneumatic with an inner tube of air or rigid, just one solid piece of rubber. A machine stretches the tire to fit the wheel rim. Workers install 12 washers, called spacers, along the hand rim. 6 of these 1 centimeter spacers can be removed later to adjust the chair's overall width if necessary. The spacers on the hand rim align with the brackets on the wheel. Workers join them with industrial strength 4 centimeter steel screws. Replacing a wheel and hand rim like this costs more than $100. You buy replacement parts much like you do car parts through specialized dealerships. Bearings make the wheels roll with ease. Installing them is a delicate operation. Workers use special custom tooling to insert the bearings with extreme precision. The tires are rigid and have no treads because they're designed for smooth indoor surfaces. An aluminum crossframe is what enables the chair to fold. They assemble it with 6 or 7 screws per side, depending on the depth needed for the seat, which they'll install later on. The front part of the wheelchair is called the front frame. Workers lubricate the parts so they'll be easier to install. This also enables the wheelchair to fold with ease. They install the rear frame of the wheelchair, then make sure the crossframe folds correctly. Workers test the height adjustment lever for the armrest. Then they install a removable aluminum footrest, setting it to the desired length. It has a heel loop to prevent the user's foot from slipping off. The chair has a foldable sling seat. It's made of nylon and attaches to the frame with 6 screws on both sides. You can adjust the armrest height from 20 to 28 centimeters and the tension in the backrest with 3 Velcro straps. The backrest is made of nylon and comes in 9 different heights. Workers insert the wheel axle into the frame, adjusting it to fit with the optional features of the chair, such as a particular style of armrest. The axle has a quick release so you can remove the wheel in seconds. This plastic and aluminum hand lever is a parking brake. It keeps the chair still when transferring to a bed or toilet. This motorized chair has an electrical controller. The user commands it with a joystick. The chair runs on 2 12-volt batteries that power up in 8 hours from a household socket. Workers squeeze the inner tube into the rear wheel rim. The air valve slips through, and the front and back parts attach with screws. Now the rear wheel can go onto the motor. They attach the seat and the joystick box, which has on-off and speed control switches. The battery pack provides 85 amps an hour. That's enough power for 16 hours or 40 kilometers. The batteries connect to the charger and controller to power up the wheelchair. A steel bumper and plastic rear hood called the shroud protect the back of the wheelchair from the elements and against minor collisions. This motorized model can glide at a leisurely pace or zoom around at a top speed of 12 kilometers an hour. The transverse flute has been an orchestral instrument since the 1700s. You play it in a horizontal position, blowing across an oval hole in the mouthpiece. The air hits a sharp edge inside, producing sound. You turn that sound into notes by pressing the keys that open and close the flute's holes. They begin production by inserting a solid steel bar into a sterling silver tube. Then, using a press, they lengthen it and taper it, reducing the diameter to 1.7 centimeters. This tube is part of what's called the head joint, one of 3 sections that make up the flute. The other sections are the center joint and the foot joint. Next, on another machine, they insert a second tube for the center joint. This device drills small holes to mark the position of each tone hole, the raised rim around each of the flute's holes. Now they insert titanium washers, called spiders, in the holes to help position the tone holes. They place a tone hole around each spider, securing it temporarily with copper wire. Once they solder the tone hole, they'll remove the spider. They solder little posts onto 3 strips of metal called ribs. The ribs and posts will later hold the flute's keys in place. Next, they use what's called a profile cutter to shave the tone holes by minute amounts to perfect the flute's sound. Now, using a wax injector and rubber molds, they create wax duplicates of the 120 different parts that make up the flute's 20 keys. Now they build what's called a tree. Using tweezers and a heated pen, they fuse the wax duplicates to a wax trunk that's 17 to 25 centimeters tall, depending on the type of flute. Then they place the tree in a perforated steel flask covered in masking tape. They pour in a liter of plaster, which hardens around the tree. Then they remove the tape and heat the flask. The wax melts through the holes, leaving plaster cavities in the shape of the key parts. The keys are made from tiny particles of silver or gold. These ones have a reddish hue because of their high copper content. The craftsmen pour a carefully measured amount into the casting machine's upper chamber. The machine heats the metal for 12 minutes. The plaster flask goes into the casting machine's lower chamber. They release molten metal into the cavities. Once the metal cools, they shatter the plaster under cold water, exposing a tree of silver key parts. Using a pneumatic cutter, craftsmen snip off the key parts. They have a dull finish because the silver isn't yet polished. Now they solder the key parts together and polish each finished key with a soft rotating brush. They also solder on a riser, which attaches the mouthpiece's lip plate to the head joint tube. They cut away excess metal from the opening of the lip plate. Then they use a lathe to cut out a hole in the head joint tube. A template ensures they position the hole correctly. Once again, they use copper wire to hold the parts together until soldering. They solder the lip plate assembly to the head joint tube using a gas and oxygen torch. Next, they mount the keys using tiny wires called straight springs. The spring helps open and close each key over the corresponding tone hole. They test each key's seal, called the pad, for air leaks. A thin strip of plastic slides out if it's improperly sealed. The pad is made up of a plastic washer and a felt cushion surrounded by a synthetic wrapper as thin as tissue paper. A pad lasts for about 5 years and is very expensive to replace, about $90. It's just one of up to 100 components in a flute, depending on the model. This company's flutes come in silver, gold, and platinum. They range in price from $9,000 to $48,000. Once all the keys are in place, a quick wipe to remove any pesky fingerprints. An engraver inscribes the serial number and company logo. After 120 hours of painstaking work, the flute is ready for its musical debut. Cowboy boots have been kicking around since the 1800s. You can wear them on the ranch or just as a country-style fashion statement. Most cowboy boots are made of cowhide and sell for about $200. For something more exotic, though, how about a pair made of ostrich skin for a mere $500? Production starts with a machine called the clicker that works like a cookie cutter, slicing leather into various sizes of soles from standard to extra wide. The clicker also cuts the other boot parts, such as the shaft, the section above the ankle. This programmable automated stitching machine decorates the shaft with embroidery. The machine works on a dozen boots at a time, using up to 15 different thread colors. Workers steam the shaft to soften up the leather. Synthetics just don't mold to the foot the way animal hides do, so this company uses only the real thing. Python skin, walrus skin, bison skin, even ostrich skin. Cow and pig skin boots make up the bulk of production, though, because they're the most affordable. Workers perforate the shaft, then layer a different colored leather underneath to create a design. This company produces 20 basic patterns, but clients can also order custom designs. They line the shaft with pigskin because it breathes better than a synthetic lining. Workers stitch together the shaft sections, including the underlays, from the inside out. Piping covers the seams. A roller turns the whole thing right side out, flattening the piping for a more comfortable fit. The next machine glues a cotton strip to the leather insole. They'll later attach this strip to the foot section of the boot. Next, they temporarily attach the sole to a plastic mold called a boot last. This makes the sole rigid while they attach other parts of the boot. They glue a hard synthetic cup to the heel section to give it the desired shape. Then they apply a fibrous cotton form between the layers that will shape the toe area. Now they attach the sole to the shaft. Using a laser as a centering guide, they stretch the toe section over the boot last, bringing the two largest pieces of the boot together. They stitch on a leather strip to attach the sections. The strip, called a welt, is a traditional part of boot making. It's what makes the boot very durable. They attach a steel shank for arch support, then apply a mixture of granulated cork and hot glue. This layer will make the boot conform to the contours of the wearer's foot. They attach the sole to the shaft with industrial-strength glue. The fact that it's glued as well as stitched means you can simply rip out and replace a worn sole. This feature greatly extends the life of the boot. A cutting machine trims off the excess leather. Then they stitch the sole to the welt. They stitch using interlacing threads. This binds the pieces even more strongly. The final layer of the sole can be either leather or rubber. It all depends on who'll be wearing the boots and where. A rancher in sunny Texas may prefer leather, but in the cold and snow, you're better off with rubber. Now for the heel. They load a driving machine with nails. The pattern varies according to the type of heel. This company produces 8 heel styles. A laser guide ensures they nail the heel to the boot perfectly centered. With a brush, they coat both the heel and the edge of the sole in black or mahogany dye. Finally, they brand the manufacturer's name in gold foil. Some boots have pull holes at the top for getting your boots on fast to make it to the rodeo on time. If you have any comments about the show, or if you'd like to suggest topics for future shows, drop us a line at www.howitismade.net.